Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In the last two videos, we have already talked about gravitational field and thermal physics questions. Today's lesson, we will start from simple harmonic motion. We will also talk about electromagnetism. We will also discuss electromagnetic induction in today's lesson. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 4 says a small steel sphere is oscillating vertically on the end of a spring as shown in figure 4.1. The velocity v of the sphere varies with displacement x from its equilibrium position according to this equation, where v is in centimeters per second and x is in centimeters. For part A1, we need to calculate the frequency of the oscillations. So first of all, we need to understand for simple harmonic motion how velocity is linked with displacement. So velocity v, this is equal to plus minus omega times a square minus x square, and we have root of a square minus x square. Here v is representing the speed and omega is representing angular frequency. So this quantity is angular frequency. So we can say this is angular frequency, and A is the amplitude of oscillations, means the maximum displacement from equilibrium position, and X is displacement at any given time. So this is displacement at any given time. So these things you need to understand about this equation. Now simply if we compare this one, so this one is over omega and this one is a square and this is x square. We need to calculate frequency of the oscillation. So if we have angular frequency, then we can calculate the frequency of oscillations. From here we can write down frequency of oscillations. This will be equal to angular frequency divided by 2 pi. Angular frequency we have, that is equal to 9.7. Now simply we have to divide this one by 2 pi. So if we divide, we will get frequency that is equal to 1.5 hertz. So the answer for this question is 1.5 hertz. This is how you can calculate. This question has 2 marks. The first mark is the C mark. If you have written this equation, you will get 1 C mark. And the second mark is the answer mark. If you have got the right answer, you will get 2 marks for this question. Very nice one. You need to understand this equation. Also, you need to understand the shape of the graph of this equation. Most of the time, they will ask you to sketch V against displacement. So the shape of this one, it can be circular, it can be elliptical. It depends on the scale of the graph. So let me write down here. So it can be elliptical. The shape of this graph means if you sketch a graph between V and X, or it can be circular. It depends on scale of the graph, mean the given scale of the graph. Second part says show that the amplitude of the oscillation is 3.4 centimeters. So we have already discussed that this quantity is a square. So this is representing a square. So simply we can say in this case we have amplitude square that is equal to 11.6 centimeters. So we need to find out A. So simply we have to take square root of this. So we have to take square root. So if we, this will be centimeter square. So if we take the square root of this, we will get in this case 3.4 centimeters. And this question has only 1 mark. If you have got the right answer, you will get this 1 mark. For the second part, we need to calculate the maximum acceleration of the sphere and maximum acceleration. So let me use different letter for that. As it is given in the question, maximum acceleration is a naught. This one has to be equal to the amplitude of oscillation, mean the maximum displacement times the angular frequency. angular frequency square. We also have negative sign here. Negative sign here, this simply tells us that acceleration and displacement, they are in the opposite directions, but we are simply talking about the magnitude of acceleration, so we can also ignore that. So we can write down a naught in this case will be equal to a, the amplitude, that is equal to 3.4 centimeters. So we have to convert this one into meters because the given unit is in meters per second per second. Omega square, omega we have already calculated, and also value of omega we already have here. This is given to us in the question. So this is omega. So we have this is 9.7 square. Now simply if we solve, we will get our answer is 3.2 meters per second per second. So this is value of a max. So this is how you can calculate. You have to be simply careful with the unit. So you have to convert this one into meters. And negative sign don't need in this case because this is telling us these two vectors, mean this vector and displacement, they are in the opposite directions. So that's the reason negative sign we can ignore. We are simply calculating magnitude. So answer is 3.2 meters per second, and this question has 2 marks. The first mark you will get if you have written here this equation, and the second mark you will get the answer mark, and you will get 2 marks if you got the right answer. Part B says on figure 4.2 sketch the variation with x of the acceleration a of the sphere. So first of all we need to understand how a and x they are connected with each other, means what is the relationship between a and x. A is equal to minus omega square x. So this negative sign simply telling us that a and x they are in opposite directions. So this negative sign, what is significance of this negative sign? This negative sign simply tells us vector x and vector a they are in opposite directions. Mean when x is positive, a has to be negative, and when x is negative, a has to be positive. So this is significance of negative sign. So we can also circle them. So we have x, when x is positive, a has to be negative, and when a is negative, x has to be positive. So these are the points we need to understand. Now let's try to understand if we sketch a graph between a on y-axis and x on x-axis, what will be the shape of the graph? So here we have a, this is equal to minus omega square x, and if we compare this one with straight line equation, in this case we can see that gradient, this is the gradient. So gradient is equal to minus omega square. So this is equal to negative, gradient will be negative omega square. So from here we can say omega square will be equal to negative gradient of a against x graph. So omega square, if you need to find out, you can find from the gradient and then multiply gradient with negative. Now let's try to sketch the graph. For this question we have already discussed that a max, this is equal to a naught when x is equal to 3.4 centimeters, and when x is positive, a has to be negative. So if you look at this axis, x-axis, we have 2 here. So we have 2.2, 2.4, 2.6, 2.8, 3.0, 3.2, and this is 3.4. So when x is positive, a has to be negative. Now we can look at x when x is negative. So we have 2, 2.2, 2.4, 2.6. So here we have 3, 3.2, 3.4 here. Now we can draw lines from here. So we can draw the line. So we can locate this point here, and we can draw a line from here, and we can locate value of a. Now simply we need to draw the straight line connecting these points. So we can connect these points. We can also extend the line. We can also extend the line here. We don't need actually these extra lines, we can clear them. So this is how you need to sketch the graph, and the gradient of this graph is equal to negative omega square. Sometimes they will ask you to calculate omega square. So this is how you can answer a nice question and a also a typical question on simple harmonic. Part C says describe without calculation the interchange between the potential energy and kinetic energy of the oscillation. So pretty straightforward question. So imagine that first of all, when the sphere is at this point, this is the equilibrium position, we can say equilibrium. And when the sphere is at the lowest point, we can imagine sphere will be here, and when the sphere is at the top position, we can imagine it will be here. Now we can also imagine this is our reference line, mean h is equal to 0, so we can say GPE here will be equal to 0. And when the sphere is at this point, its direction is changing, so this one will be at rest. So we will say V will be equal to 0. So kinetic energy at this instant of time means that this position will be equal to 0 when direction of sphere is changing. So at this point we have only EPE, elastic potential energy, and this one will be maximum. And when the sphere is at the top position, again direction will be changing, so it will be at rest. So V will be 0. So we can say kinetic energy at this point also will be equal to 0. And at this point, sphere will have potential energy plus gravitational potential energy, and this is equal to simply potential energy. So here we have potential energy. So when we are talking about potential energy, it means we are talking about EPE and GPE, the sum of EPE and GPE, and the total energy of the sphere. So total energy of the sphere at any instant is the sum of potential energy and kinetic energy plus kinetic energy. So total energy is the sum of these two energies, and potential energy is maximum at the lowest point and at the highest point, and kinetic energy is maximum at equilibrium. Speed here will be maximum, so we can say speed here will be maximum. So kinetic energy at equilibrium, this one also will be maximum. So potential energy will be minimum at equilibrium because kinetic energy will be maximum. So if you have understanding of these points, so we can write down our answer. In our answer we can mention this point 1. We can also say kinetic energy is maximum, so this will be second point at equilibrium, and we can say kinetic energy is 0 at extreme positions, mean at h is equal to 0, or we can say at the maximum displacement. So simply we can say at maximum displacement kinetic energy is equal to 0. So this is also maximum displacement, so kinetic energy here also will be equal to 0. So this is the same point. We can say when displacement is maximum, kinetic energy is equal to 0. We can say total energy is equal to sum of these two energies, and kinetic energy is maximum at equilibrium. So let me show you the answer, how you can write down your answer, and in your answer you have to mention these points. So if you have mentioned first point, you will get 1 B mark, and if you have mentioned the second at maximum displacement kinetic energy is 0, you will get the second point, and the third point you will get if you have mentioned at 0 displacement, means at equilibrium kinetic energy is maximum. Question 5 says two capacitors A and B are connected into the circuit as shown in figure 5.1. Capacitor A has capacitance capital C and capacitor B has capacitance theory C. So capacitance of this one is capital C and capacitance of this one is theory C. The two-way switch is initially at position X and capacitor B is initially uncharged. State in terms of V and C expressions for the initial charge QA on the plates of capacitor A. So we need to calculate QA, mean charge on capacitor A, the net charge on single plate of capacitor A. EMF of the cell is given to us, that is equal to V. So EMF of the cell is V. We are assuming the cell has no internal resistance. So the PD across this capacitor also has to be equal to V when this is fully charged. So QA simply has to be equal to C times V because capacitance of this capacitor is C. So we can write down this is C times V. And this question has only 1 mark. If you have written CV, you will get 1 mark. For the second part, we need to write down the expression for initial energy stored in capacitor A. For this capacitor, we have already discussed that PD across this one is equal to V, and the capacitance of this capacitor is capital C. So the energy stored in capacitor A, EA, simply will be equal to 1/2 CV square. So if you have written this one, you will get 1 mark, and this question has only 1 answer mark. For part B, it is given to us the two-way switch is now moved to position 5, means we move this one to this position. We need to state and explain what happens to the charge that was initially on the plates of capacitor A. So initially, if you look at capacitor A, it was connected with positive terminal, so this plate of capacitor will be positive and this plate of capacitor A will be negative. So when we move switch to position Y, charge from this capacitor will start flowing because initial PD across B, this is equal to 0. So we can also say initial PD across B, this is equal to 0. So I will be writing VBI. This one is equal to 0. Initial PD across this one 0. So there is a potential difference. So charge will start flowing from capacitor A to capacitor B. Actually, in this case, electrons, they will flow because there is a net charge, net negative charge on this plate. So negative, they repel each other, and negative charges will flow. They will come to this plate. And so this plate will be more negative, and this plate, because these electron, they will repel electron from here, so this plate will be more positive. And this process will continue until PD across this one and PD across A and B is the same. So we can say the final PD across these two capacitors, let's say that is VB. So when potential difference across these two capacitors is the same, charge will stop flowing. So 2 points you need to understand. Charge will flow. Why charge will flow from A to B? Because there is a potential difference, because capacitor B is at lower potential and they are in the same circuit. So charge will leave capacitor A and it will come to capacitor B. And flow of charge will continue until the PD across these two capacitors is the same. So these points you need to understand. I hope this makes sense to you. And the second thing you need to understand, are these two capacitors, they are connected in parallel or they are connected in series? Most of the students, they mostly confused about this part. If you look at these two capacitors, positive plate is connected with positive. So if positive plate is connected with positive plate, in this case, if positive plate is connected with positive plate, so capacitors are in parallel. So if we have arrangement like this, let's say we have these two capacitors, we have positive charge here, we have positive charge here, we have negative charge here, we have negative. So this arrangement, capacitors are in parallel. So very important point you need to understand. So these two capacitors are in parallel. And if we have arrangement like this, let's say we have one capacitor here, we have an other capacitor here. These capacitors, they are in series. Why they are in series? Because if this plate, let's say this is positive, this plate will be negative, this plate will be positive, this plate will be negative. So you can say positive is connected with negative. So it means they are connected in series. So this is how you can differentiate between capacitors in parallel and in series. Now let's try to write down the answer. In your answer, you have to mention this question as 2 points. So first point, because question is asking you what happens to the charge. So you will say initially charge from capacitor A will flow to capacitor B because there is a potential difference between capacitor A and capacitor B. And this charge will continue to flow until PD across two capacitors is the same. So these points you need to mention. So let me show you the answer. In your answer, you can mention these 2 points. You can say sum of the charge transfer to the plates of capacitor B. So the PD across this one will start to rise and it reach certain value. When PD across two capacitors are the same, charge will stop flowing. Transfer is because the PD across the capacitors are not equal. Or you can say transfer stops when the PD across the capacitors become equal. Second part says show that the final potential difference VB across capacitor B is given by VB is equal to V by 4. Explain your reasoning. We have already discussed when we move this switch to position Y, these two capacitors, they are connected in parallel. As these two capacitors, they are connected in parallel, so the potential difference across capacitor A, this one has to be equal to the potential difference across capacitor B. And when we close this switch, charge will flow from capacitor A to capacitor B. Capacitor A to capacitor B. So the total charge on capacitor A that will be distributed between capacitor A and capacitor B. And total charge we have already discussed. Q total is equal to CV, because this is equal to the capacitance of capacitor C times the initial PD across this one, and capacitance of this one is 3C. So Q total is equal to CV. So Q total in this case will remain same. Q total simply will be redistributed between A and B. So we can say in this case Q total, this will be equal to Q on A plus Q on B. Q on B, and Q on A will be equal to capacitance of this and the final PD across that. Let's say final PD across A is equal to VB, because we have to write on final answer in this form. And this Q total is equal to CV. And Q total across this capacitor, this will be equal to the capacitance of this capacitor times the final PD across this one. So from here we can cancel this C with this C. So we left with V is equal to VB plus 3B. So this is simply equal to 4VB. So from here we can find out that VB is equal to V by 4. So this is one way to answer this problem. So you can answer this problem like this. This question has 3 marks. The first mark is if you have written PD across two capacitors is the same. Finally, it is the same. You will get 1 mark. And the second mark you will get if you have written Q total is the sum of QA and QB. You will get the second M mark, and the last mark is the answer mark. If you got right answer, you will get 3 marks, and also you need to write down these points, so you will get 3 marks. But if you haven't written these points and you simply got right answer, you will get no marks. Now let's try to understand the same question in a different way. Now let's try to imagine we replace these two capacitors with one single capacitor. So as these two capacitors, they are connected, so let me redraw here to give you better understanding of this one. So we have these two capacitors, they are connected in parallel. We can replace these two capacitors with one single capacitor. So we can replace these two capacitors with one single capacitor. So let's say this is our new capacitor that can replace these two capacitors. Capacitance of this capacitor is C and capacitance of this capacitor is 3C. So the capacitance of this capacitor has to be equal to 4C. So simply we have two capacitors, we just connect these two plates. So area has increased, it means capacitance has been increased. So the C total of this capacitor is 4C. And what is the total charge on this capacitor? Total charge on this capacitor, single capacitor, will be equal to the sum of the charges on these two capacitors. And that one we have already discussed, that is equal to CV. So we have discussed this is equal to CV. Now we need to find out what is PD across this capacitor. So we can also imagine we connect one voltmeter across this one. So question is asking us to find out value of V. So we have said this V is VB. So we can simply say Q is equal to CV, means the Q total, this has to be equal to the C total times VB. So VB from here we can find out this is equal to Q total, and Q total is equal to CV divided by this is Q total. So this is Q total, and this has to be divided by C total. So here we have C total. So we have CV and C total, this is equal to 4C. Now simply we can cancel here C's. So we can cancel this C with this C, so we got V by 4. So this is an other way to answer this question. A beautiful way. I hope this will help you to improve your understanding of capacitors network. Third part says determine an expression in terms of V and C for the decreased delta E in the total energy that is stored in the capacitors as a result of the change of the position of the switch. We have already discussed that initial energy is stored in the capacitor when switch is at position X. We have discussed this one, that EA, we can say in this case this is equal to EI. This is the initial energy stored in this capacitor, and this is equal to 1/2 CV square. We can also calculate the final energy. Final energy, this will be equal to 1/2 C new value of C times V new square, means when we move this switch to this position. We have two capacitors, we have discussed they are in parallel, so simply we can replace these two capacitors with one single capacitor. So we can redraw our big capacitor here. So it's just like connecting these two capacitors together. Area increase, so capacitance increase. So this has capacitance C, this has capacitance 3C. So the total capacitance is 4C, and we have discussed PD across this capacitor is equal to V by 4. So simply we can write on here, this is 1/2, we have 4C, and V new, this is equal to V by 4 square. If we simplify this one, you can cancel this 4 with this 2, so we will get 2C. We will get V square divided by 16. If we further simplify, we will get this is 1 by 8 CV square. So this is E final. We need to calculate delta E. Delta E. So we have E final minus E initial. E final we have that is equal to 1/8 CV square. E initial we have 1/2 CV square. CV square. If we take LCM, we will get 8. LCM is, so this will be CV square, and here we will get 4CV square. If we simplify this one, we will get minus 3 by 8 CV square. So what this negative sign is telling us? This is simply telling us that the change in energy is negative, mean the final energy is lower than the initial energy. So energy has been decreased. Question is asking us to calculate decreased delta E. So we no need to include negative sign because already it is mentioned here, decrease. So our final answer is 3 by 8 CV square. So this is how you need to answer. Very nice question. I have discussed some important points, so you need to understand these points. This question has 2 marks. The first mark you will get if you have got value of the final energy. You will get 1 C mark, and the second mark is answer mark. If you have got the right answer, you will get 2 marks for this question. That's all for today's lesson. I hope you have improved your conceptual understanding of capacitance, and also you have better understanding of simple harmonic motion. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if these videos are helpful and these videos are helping you to improve your conceptual understanding of physics, and you want to support this work what I'm doing on YouTube, please check the link for Patreon in the description of this video. On Patreon platform, you can also get extra help from me and lot more. See you in next video, and also looking forward to see you on Patreon.